All right, let's dive into some interview prep today
That's good.
for optomechanical engineers.
Absolutely.
Love
Love.
lasers, lenses,
Yeah.
mirrors. We're talking cutting-edge optics meets precision mechanics.
Right.
And landing that dream job starts right here.
That's right. And, with the demand for skilled optomechanical engineers on the rise, having a solid grasp of how to approach those interview questions is essential.
Absolutely. And you shared some fantastic resources with us,
Yes.
including RoleCatcher's Career Guide
Yeah.
for optomechanical engineers.
Yes, it's a treasure trove of information covering, the day-to-day realities of the job, potential career paths, and even the skills you'll need to kind of climb that ladder.
Yeah, one thing that jumped out at me from that was that interdisciplinary collaboration
Oh, yeah.
is a key pro.
Yeah. It's very important.
So you're not just a lone wolf in the lab.
Not at all.
You're working with
You're working with teams all the time.
teams, yeah.
Optical, mechanical, electrical, all coming together to achieve that common goal.
I can see how that would be challenging and rewarding.
Absolutely. And, understanding that collaborative nature of the work is crucial,
Yeah.
especially as, you're progressing to those more senior roles.
Right.
And the career guide actually outlines a typical progression
Okay.
from junior engineer to principal engineer,
Nice.
highlighting the evolving responsibilities at each stage.
That's super helpful for context
It is.
for anyone navigating this career.
Yeah.
But
Yeah.
let's not get ahead of ourselves.
Right.
Before we can lead teams and design groundbreaking systems, we got to ace that interview.
Exactly. And
Yeah.
that's where the real meat of our deep dive comes in.
Okay.
You've shared 8 common interview questions
Okay.
that optomechanical engineering candidates often encounter.
Perfect. So let's break them down one by one
Yeah.
and equip our listener with the knowledge and strategies
Yes.
they need to shine.
Absolutely.
First up, the classic.
Okay.
What inspired you to pursue a career in optomechanics?
Oh, that's a good one.
Right.
This question might seem simple, but it's your chance to showcase genuine passion and connect it to your skills and experiences.
So more than, I've always been fascinated by science.
Think back to what truly ignited your interest.
Okay.
Was there a particular project, perhaps during your studies, that sparked your fascination with optics or mechanics? Or maybe you've always been drawn to the idea of creating high-precision systems.
Right.
Share a specific anecdote
Okay.
that demonstrates your genuine passion for the field.
I love that making it personal and memorable.
Yes.
And this is where I think RoleCatcher's AI feedback tool comes in.
Oh, absolutely.
Right.
RoleCatcher doesn't just give generic feedback. It uses AI to analyze your answer in the context of specific job roles, helping you tailor it for maximum impact.
It's specific to the job.
Think of it as your personal interview coach,
Okay.
ensuring your responses resonate with potential employers.
All right, on to question 2. Describe your experience with designing optomechanical systems.
This is where you delve into the nitty-gritty of your technical expertise.
Okay.
Don't just list projects, showcase your problem-solving process.
So walk us through a challenge
Right.
you faced in a design project. How'd you approach it? What'd you learn?
Exactly. And a potential follow-up question here could be, what were some of the trade-offs you had to consider in your design?
Oh, okay.
Be prepared to discuss how you balanced factors like performance, cost, and manufacturability.
So demonstrating a deeper understanding
Absolutely.
of the complexities
Yes.
involved.
Yeah.
Okay, moving on to number 3.
Okay.
How do you ensure the precision and accuracy of optomechanical systems?
This question is all about highlighting your knowledge of metrology, tolerance analysis, and testing procedures.
Break those down for us a little bit.
Of course, so metrology refers to the science of measurement,
Okay.
making sure your components and assemblies meet the required specifications with extreme accuracy. Tolerance analysis involves determining the acceptable range of variation for different parameters in your design.
Okay.
And testing procedures are crucial for verifying that your system performs as expected.
So it all fits together perfectly and functions flawlessly.
Exactly. You want to demonstrate a deep understanding of the tools and techniques used to achieve that level of precision.
Right.
Be prepared to discuss specific tools like interferometers or coordinate measuring machines and how they're employed in quality control.
Okay, now this might be overwhelming.
It can be.
For someone starting out in this field,
Right.
what advice would you give?
It's important to focus on the fundamentals, and the RoleCatcher Guide actually emphasizes quality control analysis and systems evaluation as core skills for optomechanical engineers.
And how can someone showcase those?
By demonstrating a clear understanding of the principles involved.
Okay.
Talk about your coursework, any lab experience you've had, or even personal projects where you've had to pay close attention to precision and accuracy.
So showing that you grasp the importance,
You
even without the experience.
It's about showing that you grasp the importance of these concepts and are eager to learn more.
Okay, that's encouraging.
It is.
It shows that even early on in your career, you can still make a strong impression
Yeah.
by highlighting those foundational pieces.
Yeah.
All right, let's move on to question number 4. How do you incorporate thermal and vibration mitigation into your optomechanical designs?
Now this is where your understanding of material science, structural mechanics, and environmental factors comes into play.
So designing systems for real-world conditions.
That's right. Optomechanical systems are often highly sensitive to temperature fluctuations and vibrations.
Oh,
You need to be able to explain how you would minimize these effects through careful material selection, structural design, and even active control systems.
so choosing materials with low thermal expansion coefficients
Exact.
or designing dampening mechanisms.
Precisely, be prepared to discuss specific examples of how you've applied these principles in past projects or how you would approach a hypothetical design challenge.
And I bet RoleCatcher's AI could be helpful here too.
Absolutely.
Right.
It can analyze your response and suggest ways to make it more specific and relevant to the types of projects the company you're interviewing with typically handles.
Okay, so it's specific for each opportunity.
Absolutely.
That's fantastic.
Yeah.
Okay, on to question number 5. How do you balance the trade-offs between performance, cost, and manufacturability in optomechanical design?
This is a classic engineering challenge
Yeah.
and one that really tests your strategic thinking skills.
So it's not just about designing something amazing. It has to be buildable
It does.
and on budget.
Exactly. Be prepared to discuss specific examples of how you've weighed these competing factors in your design process.
Yeah.
Maybe you had to choose a slightly less expensive material to stay within budget, or simplify a design to make it easier to manufacture.
And a potential follow-up there is, can you describe a time when you had to make a difficult design decision? And how did you justify your choice?
That's a great point. It's all about demonstrating your ability to think critically and make informed decisions in complex situations.
So this is where we separate those who just follow instructions from those who can think outside the box.
Precisely.
All right, let's tackle question number 6. Describe your experience with finite element analysis, FEA, and computational fluid dynamics, CFD, in optomechanical design.
So this one delves into the realm of computer-aided engineering tools, which are essential for modern optomechanical design.
What are FEA and CFD?
Right, so FEA is a powerful technique for simulating how a structure responds to various forces and stresses.
Okay.
Think about analyzing how an optical mount will deform under load or how a lens will behave under thermal stress.
Okay.
CFD, on the other hand, focuses on simulating fluid flow and heat transfer.
Got it.
This is crucial for optimizing cooling systems, predicting airflow patterns, and ensuring thermal stability in your optomechanical designs.
So using computer models
Yes.
to predict how things work.
To predict how your designs will perform in the real world, exactly.
Great.
And when answering this question, be specific about the software packages you've used, NSYS, COMSOL, or others, and the types of analyses you've performed.
So don't just say that you know NSYS.
Don't rattle off software names.
Right, give us specific
Connect your experience to real world outcomes.
examples.
Quantify your experience whenever possible.
Okay.
Maybe you could say, my CFD analysis helped reduce the operating temperature of a laser diode assembly by 15%, improving its lifespan and reliability. Numbers speak volumes.
Okay, good advice.
Yeah.
Last question in this section. How do you ensure the manufacturability and scalability of optomechanical systems?
This is where your understanding of manufacturing processes and design for manufacturability, DFM principles, comes in.
So not just that it works in theory, but that it can be built.
Exactly. Be prepared to discuss techniques like using standard components, minimizing part counts, designing for easy assembly, and selecting materials that are readily available and compatible with common manufacturing processes.
Now, this is where researching the company comes in handy.
Oh, absolutely. If you know what manufacturing processes they typically use, you can tailor your answer to demonstrate that you're thinking about their specific needs and challenges.
Showing that you're practical,
You got it.
as well as a good designer.
Yeah.
And RoleCatcher's CV resume builder
Yes.
can help with that too.
Especially when it comes to highlighting your skills and experience in a way that aligns with the specific requirements of each job you're applying for. The AI-powered tool helps you craft compelling resumes and cover letters that showcase your value to potential employers.
That's awesome. Okay, I think we've covered a lot of ground
We have.
in this first section. What do you
Yeah.
say we take a quick pause, come back and dive in a little deeper?
Sounds good. So we were talking about, designing for manufacturability and
Ah,
scalability.
yeah.
But, even the most meticulously designed system requires a skilled team to bring it to life.
Which leads perfectly into the final question in this set.
Okay.
How do you collaborate with cross-functional teams in optomechanical design projects?
This is a good one. This question really aims to assess your communication skills, teamwork abilities, and understanding of the collaborative nature of optomechanical engineering projects.
So you gotta be a team player.
You do optomechanical projects often involve engineers from diverse backgrounds, optical, mechanical, electrical, software, and more, all working together. Effective communication is key.
What are some examples that someone could give?
Think about situations where you had to explain complex technical concepts to colleagues from different disciplines.
Oh,
How did you ensure everyone understood the design choices and potential trade-offs?
right.
Or perhaps you faced a conflict within the team regarding design decisions. How did you navigate that conflict and reach a consensus?
Bridging the gap.
Yeah, bridging the gap between those different technical perspectives and working effectively towards a common goal.
I like it.
And don't forget to mention any experience you have with project management methodologies like Agile or Waterfall.
Oh.
These can be valuable assets in demonstrating your ability to work within structured team environments.
So organization is key.
It is.
I want to circle back to RoleCatcher's AI feedback tool.
Okay.
I'm still amazed
It's amazing.
by how it tailors answers to specific job roles.
It's a game changer. Really, different companies have different priorities, cultures, and even technical jargon. RoleCatcher's AI analyzes your responses in the context of the specific job description and company profile, providing feedback that's incredibly targeted and actionable.
So it's like a personal coach,
Exactly.
but it knows the company.
It does. It can suggest ways to rephrase your answers, highlight specific skills, or even adjust your tone to better align with the company's values.
That's valuable.
It is.
Okay, I think we've covered those 8 questions thoroughly.
Yeah.
Now let's
Let's
shift
go.
gears a little bit and talk about some broader career insights
No.
from that RoleCatcher guide.
Sounds good. One of the most valuable aspects of the guide is its breakdown of the typical career path for an optomechanical engineer.
Yes, outlining that evolution from junior engineer to principal engineer
Exactly.
with clear explanations of the responsibilities.
Yeah, for someone just starting out, understanding this progression can be incredibly helpful in setting career goals and identifying areas for professional development.
So walk us through those key stages.
Okay, so at the junior engineer level, the focus is typically on developing foundational skills, assisting senior engineers, and contributing to specific aspects of a project. You might be involved in tasks like running simulations, conducting experiments, or documenting design choices.
Lots of learning,
Yeah, learning the ropes.
building that foundation.
Exactly. As you progress to a senior engineer role, you'll be expected to take on more responsibility, lead smaller projects, and mentor junior engineers.
Okay.
You'll also likely have more autonomy in making design decisions and solving technical challenges.
So becoming more of a leader,
You
got problem solver.
Exactly. And at the principal engineer level, you're essentially the go-to expert in your domain. You'll be leading major projects, setting technical direction, and mentoring a team of engineers. You might even be involved in business development or strategic planning for the company.
So quite the journey,
It is.
but it sounds like continuous learning is important.
Absolutely. The field of optomechanical engineering is constantly evolving with new technologies and applications emerging all the time. Staying current with the latest advancements is crucial for success at any stage of your career.
The guide did mention some emerging trends,
Oh, yeah.
creating new opportunities.
Yes. Areas like adaptive optics, fiber optics, and laser interferometry are experiencing significant growth driven by advancements in fields like telecommunications, biomedical imaging, and even space exploration.
That's exciting.
It is. It truly is. And for someone passionate about science and engineering, there's perhaps no better time to be entering the field of optomechanical engineering.
I'm feeling inspired.
Good.
We've covered a lot of ground,
We have.
from those tricky interview questions
Right.
to the exciting career path.
Yes. And while those interview questions might seem daunting, remember that preparation is key.
Yeah.
Take the time to reflect on your experiences, practice your answers, and leverage tools like RoleCatcher to fine-tune your approach.
Great advice.
Yeah.
Before we wrap up, I'm curious, what makes a truly exceptional optomechanical engineer stand out?
It's A few key qualities.
Okay, what separates the good from the truly exceptional?
I'd say first and foremost, a deep-seated curiosity. The best optomechanical engineers I've encountered are constantly asking questions, exploring new ideas, and pushing the boundaries of what's possible.
So that desire to learn and grow.
Absolutely. They're not content with simply following instructions or applying well-established techniques. They want to understand the why behind the how.
Right.
And they're always seeking ways to improve and innovate.
That spark of intellectual curiosity.
Precisely. And this ties into another crucial quality.
Yeah.
A problem-solving mindset. Optomechanical engineering is inherently about tackling complex challenges, often involving multiple constraints and competing objectives.
Balancing those trade-offs.
Indeed, the best engineers thrive in these environments. They approach challenges with a systematic and analytical mindset, breaking down problems into manageable pieces and considering multiple solutions before arriving at the optimal approach.
So it's not just about being smart, it's about that tenacity.
Yeah, that resilience to persevere through those tough design dilemmas.
Right, and not being afraid to fail.
Exactly. They're not afraid to iterate, to experiment, and to learn from their mistakes, and they're always seeking feedback and collaborating with others to refine their ideas.
Which brings us back to those teamwork and communication skills.
Absolutely. Being able to articulate your ideas clearly, listen to others' perspective, and work effectively in a collaborative environment is crucial.
Absolutely.
And finally, I'd say that a genuine passion for the field is essential. The best optomechanical engineers I know are truly excited about what they do.
Yeah.
They see the potential of their work to make a real impact, whether it's advancing scientific discovery, improving healthcare technology, or enabling new forms of communication.
It fuels that creativity.
Precisely so. To recap, curiosity, a problem-solving mindset, strong communication skills, and a genuine passion for the field. Those are the hallmarks of a truly exceptional optomechanical engineer.
Those are fantastic insights, and RoleCatcher can really help support that journey.
Absolutely. From their AI-powered feedback tool to their comprehensive career guides, they've got you covered at every stage of your journey.
Now, before we wrap up, you mentioned cavity optomechanics.
Oh, yeah.
As a really mind-bending area of research.
It is. Cavity optomechanics explores the interaction of light with mechanical objects at a very fundamental level.
Okay.
Often within tiny, carefully engineered cavities. It's a field where quantum mechanics meets mechanical engineering, leading to incredible advancements in areas like precision sensing, quantum computing, and even the study of gravitational waves.
So applying these principles to some really groundbreaking areas.
It truly is a testament to the power and versatility of this field.
I love it. Okay, well, I feel like we've given our listener a really solid foundation to ace those interviews and embark on a rewarding career.
I agree. Remember, preparation is key. Leverage those resources, practice those answers, and most importantly, never lose that passion for exploration and discovery.
Until next time, keep diving deep.